This is Space Minds by Space News. In this episode, co-host David Ariosto talks with Nathalie Cabrol, director of the Carl Sagan Center at the SETI Institute, who explains why the red planet may hold answers about extraterrestrial life as well as our own origins. Then our hosts discuss the latest news, including space-based tools used for war and the attack on Iran's nuclear facilities. They then discuss Europe's launch capability and their efforts to be less reliant on SpaceX.
Dr. Nathalie Cabrol, you are the director of the Carl Sagan Center at the SETI Institute, which stands for the Search for Extraterrestrial Intelligence. It's so good to have you on the show.
Thank you very much for having me.
You're also the author of this superb book called The Secret Life of the Universe, an astrobiologist's search for the origins and frontiers of life. And so I think that's a kind of a good place to kind of get into this conversation. My first question really is why? Why have you dedicated your career to sort of understanding the origin and the nature of life in the universe, not just out there, but also right here on Earth?
Yeah. Well, I often have this question and I always make the same response, which is, I was born in France, and we have this cartoon character in France that's called Asterix, and it has this companion whose name is Obelix, and those two are Gauls, and they are resisting the Roman Empire. And the whole story is about druids and magic potion, and that's why they still can resist, because of the magic potion. And Obelix is this gigantic Gaul, is really, really big, and cannot have magic potion because he fell into the cauldron when he was little. So that is what happened to me. I fell into the cauldron when I was little. I have no explanation. I was born like that. I always wanted to do that.
I mean, that seems to be a theme that a lot of the people on this show sort of are bitten by the bug, so to speak, at an early age. But I like when I look at your career, it seems like it dovetails with a number of things that were happening in space. So you had the NASA's Viking missions, which were the first U.S. mission to successfully land on Mars. You had Mariner 9, which was first spacecraft to orbit the red planet. So I'm kind of curious, like, what role did those missions play in your thinking? Because your PhD centers on water on Mars, and sort of like when you think about that and the broad scope of what Mars may have looked like, especially back then, pretty similar to Earth, like polar caps, seasons, tilts, questions of water, where it ponded, riverbeds, all of these things seems to kind of coalesce in terms of where you were and what you were focusing on.
Everything in life is a question of timing, and I have to thank my parents for that. I was pretty much born at the same time as planetary exploration. In fact, planetary exploration was born a few years before me, but I was 5-year-old when Armstrong, stepped foot on the moon, and then I really did not remember Mariner 9. I was too little. But really, that was the time when we went from science fiction and Mars, potentially having Martians, little green men, and crystal cities at the surface, to a reality, a scientific reality that is even, for me, even more intriguing. Because, well, as you just mentioned, you don't need to invent any words to describe Mars. Yeah. You have valleys, you have dunes, you have channels, polar caps, volcanoes. This sounds really, really familiar. My first recollection, my first excitement is Viking and Voyager. And those two really, then I was old enough to start putting things together, which was my call that I felt very, very early on when I was looking at the sky, and all of a sudden having these planetary landscapes in front of me. And why did it start with Mars? Because Mars was the place that was available at the time to study. I mean, really study. Voyager was flying by, so we had images, some of them, and they were spectacular. But Viking was really the first planet that had an integrated program of exploration. So little by little, we acquired a lot of data, enough for me to do a master and a PhD on water on Mars, but not necessarily by choice.
Mm.
It was there, and this is where we were starting at the time.
It almost strikes me that that there's almost a natural boom and bust cycle to a lot of these things, in the sense that you had the Apollo program, you had Voyager, when we're like pushing beyond the realms of our own solar system. And then there's lulls, and then you see sort of resurgence. And it strikes me we're in a period of resurgence now, not only in terms of the commercial sector, but all of these sort of new technologies that are coming to bear, not only with James Webb, not only with the nature of AI and the intersection of sort of quantum technologies, as we start to kind of understand the nature of these things a little bit more. And yet it's also coming at a time of great pushback with regard to science, growing skepticism of so-called experts, questions about funding in terms of these things. So it's, you know, I wonder if we're sort of entering this almost like Copernican-like reckoning in terms of who we are, where we're at in this sort of technological adolescence of humanity, that's coupled with this moment of real retrenchment from science. And I just wonder how you square the two.
Yeah, it's interesting because this retrenchment exists, but that depends where you look.
Yeah.
You were mentioning exoplanet, and in my book, I talk about the Copernican revolution because, well, they changed everything. We mentioned Copernicus just because Copernicus allowed us to figure out that we were not the center of the universe, right? That the sun was not orbiting around the Earth, that the Earth was orbiting around the sun. But still, we felt like, we are special.
Mm.
We are the witness of something. We can witness the sun and the wonders around us and try to understand them, by measuring them, or for other people, just to have faith that, we are so special that God put us there.
Yeah.
And all of a sudden we turn those telescopes, and every single star you look at, there's a planet orbiting around. There are gazillion, and this is a very, very, scientific measure, especially considering exoplanet.
Yeah.
They're everywhere. Not only they are everywhere, but they are not exactly like us. We are unique in that sense. Well, we haven't found yet another solar system per se, but we have found other version of it. And we've learned that there are planets that don't exist in our solar system.
Yeah.
And this opened such an incredible new, it's just like a new breath, because you see all these new planetary landscape that you can, foresee and model. Those planets, they have different habitability. Some of them don't, in terms of the life as we understand it. They are too hot or too cold or too weird, for what I know. But many of them are habitable for life as we know it. Doesn't mean that they are the same as the Earth, but we're talking about super Earth, hot Jupiter, Ischian worlds, and all of a sudden your imagination takes flight. And as a planetary scientist, I am starting to put together the work interstellar extreme environment with these new worlds, and AI come on top of that, helping us model and see, what kind of atmosphere, what kind of environment could develop if we were putting all of those together, and if they could survive in the first place. So in that sense, there is a huge revolution, and this one is pretty obvious. It's in our face. It's happening every single day, to the point now that it has becoming so main avenue to talk about exoplanets, so they rarely make, the news anymore, just except when you have some particular study. But there are other revolutions going on, much quieter one. And I think that these will have the most impact in the coming years. And those are happening in the background right now.
You mentioned whether we're special. And I think maybe that strikes to the core of this, because there's been no indication of anything beyond this planet that exists. And yet, foundationally, in terms of what the Drake equation, sort of that formulation in terms of the possibility of life out there suggests, I would think by virtue of what you do, your answer would be no, we're not special. But I'm curious. I put that answer to you.
We are special in the sense that we exist, and so far we are the only, data point that we know.
Yeah.
But at the same time, we don't understand what life is. To this day, after several decades of searching, for life, its origin in nature, whether it's microbial or technologically advanced, we do not have a definition for life. We do not have a definition for intelligence, and we don't have a definition for consciousness, which are so very critical to understand who we are and why we even exist. So in that, we are very special because we can, ponder over these questions and try to seek answers.
Well, I guess when we think about with that specifically, I wonder if the public's idea of this notion for the search of life is far too narrow, not only in the scope of what you just mentioned, the possibility that the universe is full of bacteria, potentially, at least of which we're talking single-celled organisms. At least that's like a driving theory. There's not evidence to suggest that beyond like maybe some biological signatures or sort of possible evidence or indications of past life. But also, it seems like there's two other sides to this as well, or at least two other sides. There's this once the search for archaeology, in the sense like that the universe as we know is 13.8 billion years old. And so the idea that human civilization, which sort of represents fractions upon fractions of a moment in a time in that moment, somehow lines up with another entity that could suggest complex life would seem incredibly rare. But I think the bigger question is that, is it like just hubris and arrogance to think that other forms of life, particularly complex forms of life, would be distinguishable through our sort of natural physical processes and how we detect things?
This is a very interesting question in many respects. The first one is that our search, whether you're looking for microbes or looking for advanced beings, is still very anthropocentric and geocentric.
Yeah.
And in fact, when we say we're searching for life, we are not searching for life. We are searching for the coevolution of life and environment. Life doesn't, just appear through the strike of a magic wand. And who we are, us, anything in the biosphere, is the result of 4 billion years of evolution, of co-evolution on this world. And that includes this neural network here, the neural box that we have. We are completely attuned to the terrestrial environment where we evolved for so long under so many forms. And you have to think that this is exactly going to be the same for any type of life, whether simple or complex, anywhere else. And so thinking that they would, approach questions the same way we do, because again, the way we think, the way we see the world is really related to our convolution. Thinking they would be the same as us, I think this is a big, big step, And so far we are searching, following this anthropocentric and geocentric view, but this is what we have right now, okay? And it's not completely stupid for a number of reasons. Fact is that the bricks that make us, the bricks of life, they are very common. They are the most common stuff in the universe, and they are even more ancient than we thought they were, thanks to James Webb. We know that, we can see complex organic molecules 12 billion years in the past, barely right after the universe, formed. And so there is that. So the chemistry that makes us is probably very common. That doesn't say that we are going to look alike or think alike, just because there are so many, many possibilities just with that, with these bricks. The number of, amino acid, the geometry of the molecules. If only one thing changes, you change a lot of things. And also, there has to be some common ground throughout the universe. If they are part of this universe, then they would have to follow some of the same rules, right?
This universe, I like.
Well, yeah, you have the multiverse. We can go. Let's start with, we have enough problems right here.
Yeah. There's a progression in terms of
Yeah.
but let's start there. Let's actually start right here on Earth.
Right. Yeah, and just to finish the thought here, just because of that, there will be some convergence of form, like an entity that has to survive and evolve to be advanced means that was able to survive for quite some time in an environment, whatever it is. So it has to be able to interact with that environment. If it wants to communicate with you or just is curious about the cosmos, then it has to invent some technology, understand the rules of the universe. Curiosity is going to be something we share. I think that there is no doubt about it. The sharing of information, the sharing of energy, or the way we expend energy is also something. So the small version of this is that there are some fundamental principles about what life could be about.
Well,
And
I'm sorry, go ahead, finish.
no, I mean, and that goes back to the quiet revolution that's going on right now, which is that in astrobiology, which is that for decades, we have been searching for the origins of life, which bottlenecks us into environments that are favorable of the type of chemistry and biochemistry we are made of, to slowly but surely lean into the nature of life, which
I
is
think even that I think is one of the most interesting things, because before
to
we
me
start,
as well. This is why I'm very interested in right now.
yeah, because before you even expand out in terms of all these other definitions of life and how we might sort of extrapolate out in terms of, what constitutes life by other definitions, part of what you do is not only looking out there but looking here, right, where life can exist and where it may not seem possible on Earth. And so it's just like the nature of things like tardigrades, I would think, these uber tough water bears, the microscopic water bears of sorts, just sort of in the nature of their capacity to survive, at least for a little while, even in the vacuum of space, the near vacuum of space, it just sort of changes the math a little bit in terms of what we think about what's possible, or at least it broadens the definition a bit. And so I wonder, like, when you think about that path from the simple to the complex, and like how rare or inevitable that transition might be in the cosmos, that strikes me as sort of like a fundamental question in terms of your research, in terms of what you do.
Yeah. And some of the researchers, and I'm really, leaning with all my heart and some of my brain, because some of what they do goes way beyond it's not my expertise. But some of them are telling you right now that life is the inevitable result of thermodynamics, because it's the best way to fight entropy. And so what they are saying that is there is a fundamental force in the universe that organize whatever is there, and is bound to create living forms. So this is where we're starting to talk about the nature of life, which is not, that doesn't make life a thing. And that's, I think, the biggest issue right now that we have in front of us, is that for us, something is living when we can recognize that it is, that we can see it, that we can measure it. But life doesn't care about that. And we already have some part of this paradox embedded in what we are searching right now, which is that most of the community agrees that life did not appear on Earth. We are going back to the magic, wand striking. It's a transition. It's a transition from something to something else. But if it's a transition, is there even a sense to put a demarcation somewhere?
Right.
And then the horizon broadens really, because you are in front of a cliff and it's just, the difficulty with that is that some completely shift the paradigm and tell you that life is a property of the universe.
Mm.
How do you prove that? How do you falsify this theory? Not to mention that this is the most biased experiment because we are part of it.
Yeah.
We are both the observer and the observation. So the idea would be that there is something about the universe that is bound to make things that ultimately we will recognize as living, which is, if we want to go very fast over this, to rearrange the flow of energy and the flow of information. But then you have to acknowledge that what is information?
Right.
Information is energy decoded by something that's capable of understanding what it says. So today, we are at this incredible moment in time where we are opening doors over an endless horizon. Life is not only an experiment in this vial in the lab, it's not the Milner experiment anymore.
Right.
Although this is important because we understand maybe where this process happens in terms of environment and in terms of chemistry. But it's only the part we can see. That's only the tip of the iceberg we can understand.
And that's not to say even the least of what we're potentially even developing on this planet in terms of.
And there is that. But if life is a universal principle, it's going to organize itself in ways we cannot fathom at all. And to me, this is incredible. And if you want to push really the envelope, to the very end, I would say this is the kind of life we can imagine with our understanding, the current understanding of the physics that surrounds us in the universe, which of course is a reflection of the instruments we have.
Right. Okay, so sort of the last question, the last couple of minutes that we have here, we've kind of gone big picture now. I want to sort of center now a little bit more to the here and now. We did that a bit with Earth, but I'm curious, when you look at Mars, and it's sort of coming full circle here, and you think about the nature of this upcoming Mars sample return mission, is it your contention? Is it your maybe your hope or your sort of understanding just based on precedent that we may be in for some surprises that make what NASA's Curiosity rover has found in terms of organic compounds like akin to that, or perhaps even more, or perhaps less. I don't want to sort of suppose or speculate too much in terms of this, but that seems like a seminal moment that's coming up, not only in terms of the science, but in terms of a broader consciousness, in terms of what's out there and where we stand within it.
Yeah, and it's definitely intriguing. And, if we were seeing this on an exoplanet, I would be a lot more prudent because obviously we don't know the environment on an exoplanet. That's the issue we had. And I had to write a commentary for The Guardian a couple of weeks ago for K218b because people were, some scientists were saying we're seeing this molecule and it's potentially a biosignature. This is hard to do when you don't know the environment because then you cannot extract the signal of life from it. This is different on Mars. On Mars, we know the environment fairly well now. And obviously, the ratio of carbon-12 and carbon-13 that you are referring to which is usually, but not always, associated with the presence of life,
Right.
is
There's some
very
caveats in
intriguing.
there, admittedly. Yes.
Yeah, it's very intriguing because life is lazy, and if it has to break carbon bonds to, get energy and metabolize, then it will go for the weakest one. And so C12 is the one preferred over C13. And there is this other thing with the methane. And the methane is here. People were very excited when we were seeing that it was seasonal. I said, bummer, it's seasonal, which means that, it may just be related to more melting, etc. But it can also be, methane is such a problematic signature because half of the ways you can form methane, and there are many, are purely geological or cosmic, and the other half is biological. But let me tell you that Mars is a Rosetta Stone, and I'm not going to get into it, but it has some of the secret we couldn't keep because of plate tectonics and erosion here on Earth. And there are so many possibilities. The first one is that life never appeared on Mars. And that's a possibility we have, until we can prove the contrary. It's an hypothesis. Another one is that life appeared on Mars and is very different and couldn't stay at the surface, but considering the environments we know still today at deep in Mars, it's probably still there and thriving because it has a very, very stable environment deep down. If we find it, we will know if it's local, because it will be different. It will be adapted to its environment. And then there are a couple of other possibilities which are really fun. It's to think that because Mars was cooled down before the Earth and had an ocean before the Earth, but still was bombarded by big asteroids and impact, lots of material was ejected. It's possible that some organic material or even prebiotic stuff or early life made its way to Earth and find a great environment to thrive, which means that the Martian we're seeking maybe are, we are those Martians.
So inherently, we are all,
exactly.
At our core, at least according to this theory, we're all inherently
Yeah, but we will know it because if we find it, there will be some genetic footprint, fingerprint, I'm sorry, to tell us that. The one way is not the only way. The other way is true too, which means that the Earth could have sent some material to Mars, and for 1 billion years, Mars had a very similar environment as the Earth. So maybe we are parents, and maybe it worked both ways, which would be even more fun.
Right.
And maybe the third way is true, which is that you have a local life on Mars and contamination both ways. So, you can think about this in many, many ways, but we are at the threshold of something really fascinating. But to me, beyond all the planets and moons that are so, enticing right now. Yeah. To me, the search for the nature of life.
Dr. Nathalie Cabrol, I could talk to you for the next 6 hours. So we're going to have to carve out some time at that point. But thank you so much for joining us, the director of the Carl Sagan Center at the SETI Institute. It was my absolute pleasure having you on the show.
Thank you.
Now for Space Takes, where our hosts tackle the buzziest industry topics.
David, we're doing this in person.
We are. This feels strange, actually, in some ways.
We're not on Zoom. I'm not a square.
Yeah. I don't know how I feel about you being this close to me, frankly, but we'll see how it works.
Let's start by talking about this weekend. A lot of news about Iran, the bombings there.
Yeah.
Space-based capabilities are, I think, what we're going to talk a little bit about today, but you get us started. Tell me what your takeaways there are.
Well, just all the reporting on the commercial application in terms of the imagery that came out. I mean, Maxar is one of the companies that kind of comes to the forefront, and they always do in terms of some of these geopolitical hotspots. But, hypersensitive regions like the 3 main facilities in Iran, in Natanz, Fordo, and Isfahan, are clearly areas that have been under consistent surveillance. But just thinking about this in kind of the broader scope, about how you can kind of evaluate the real-time changes by virtue of how many times these satellites are imaging these regions, and how much the satellite imagery is changing too. I mean, we talked with folks both at Maxar, but also at Planet, and just the sense of some of these new sort of AI-powered technologies in terms of the surveillance. is changing the scope of not just the visual acuities that are natural to the human eye, but also some of this hyperspectral imaging that cuts through clouds, or thermal imaging. You can't exactly tell sort of the power output of something like that, but nonetheless, I mean, you get a much more comprehensive and sort of real-time picture of what some of these facilities look like. And so in terms of geopolitical analysis, intelligence gathering, whether the strike was effective, what was leading up to the strikes, all the trucks that were sort of gathering in front of some of these sites, what might have been taken out, what is sort of positioning now. It's just a much more complete picture. Not fully complete. I mean, we still don't quite know exactly how effective these strikes were, but certainly it's sort of a sea change than had we done this 10 years ago.
Right, and I'm struck by, we don't think of this as a space war. Yeah. This is not an on-orbit battle. Yeah. But when we talk about integration, when we talk about multi-domain, this is a pretty good example of that. You brought up the pre-strike imagery. We've seen a lot the last couple of days in that post-strike imagery, really detailing some of the places where the bombs fell. Yeah. I think we all take for granted the role GPS plays, especially military GPS when it comes to some of the Tomahawk missiles that might have been used, some of the munitions that were used. So obviously the role of GPS. My colleague Sandra Irwin mentioned, they had to fly in radio silence. So there's probably satellite communications that are used here as well. So there's a lot, and so it sounds like, hey, this is very traditional warfare. Yeah, but it's not. And then the other element of this is, what role did cyber? What role did UW? What sort of shutting down any kind of attempt to limit communications, and all of that, like that. It's much more sophisticated when it seems, and the storyline is basically, hey, plane flies, drops bomb. Right. And it's not nearly that simple.
Well, right, and I think when we talk about sort of the nature of warfare in the space domain, the thinking is always this sense of Star Wars and these battles on orbit, and clearly there are ASATs that are being developed and different laser technologies, and you mentioned cyber and some of the jamming capabilities that happens on orbit. So there is kinetic activity that potentially happens, but the lion's share of what we're seeing now, not only with Iran, but what happened with Ukraine in terms of just the sort of the eyes and ears of the battlefield increasingly oriented on orbit. And then when you throw on top of that sort of this growing push for data processing to happen on orbit, we talked about sort of the advantages that space has in terms of the ultra cooling and the constant lack of day-night cycles in terms of solar power. That you have this sort of like a whole sense of not only sort of the potentially global economy eventually, but certainly the military space moving in a way that is heavily reliant on the orbits. And then when you think about that, you think about the vulnerabilities. Yeah. And I think that's maybe the Achilles heel of a lot of this that we don't necessarily talk about as much. Iran, a sophisticated nation in as far as it can take itself, but it doesn't have the resources that a Russia might have or a China might have, certainly. So, growing questions about sort of that burgeoning competition. We've talked about Taiwan a few times on this program. So, sort of long-term questions about a much more sophisticated adversary. There's questions, not least of which has to do with GPS.
The other thing I would add is, think about how much of this you and I can see, how much the everyday person can see. Those images are fairly readily available. And,
30 centimeters, right? It's just a piece of paper you're getting from Leo.
And there was a time when this was exclusively the domain of the National Reconnaissance Office or the intelligence community, and we couldn't see exactly what was happening there. Right. And now we get to look at those photos, and they're out within hours. I know Saturday night when all of this happened, I was looking online at some of the imagery online that said, hey, this is where you could you could see some missile warnings, some
Right.
some
Your
of
living
that.
room has now become the situation room in a sense.
In a weird sense, it's confirming, like, yes, there are fires in these areas.
But you make a good point, though, in the context of it's not only that, but just how easy it is to get on orbit now, and how easy it is to not easy, but how single actors can potentially take down satellites by virtue of cyber strikes. You've seen banks of computer programmers in places like Ukraine already kind of targeting different modalities within the Russian apparatus. But these things aren't not necessarily the purview of state actors anymore. And so what does that mean when you can not only get on orbit, but you can evaluate the battlefield all by access to commercially available satellite imagery, and maybe a starter kit that you can start in your garage. I mean, it's a democratization in a terrifyingly new kind of bold way.
Right,
Yeah.
and you're watching it all on your feed.
Yeah.
So that's a lot of fun. Second story we want to talk about this week: launch. So let's talk a little bit about. I know you have a story in mind with Arianespace.
Yeah. Well, listen. I think the broader message is that Europe is trying to sort of catch pace. Keep up and lessen its reliance on SpaceX, which, frankly, is not just a European story. Everyone is trying to reduce their reliance on SpaceX. Except for maybe the Chinese. But they're aiming for 10 launches. I think at the end of this year.
Yep.
When you look at what the Falcon family has done just in 2024, I think there was 134 launches last year.
Around there.
So you talk about like this wide chasm between where they're at and where they kind of have to get to in terms of commercial viability. But the big question that I have is that 6 is still expendable, right? These are single-use rockets, and in the age where skyscrapers sort of land vertically, how do you catch pace in terms of that landscape? And I know they have sort of these I think it's Vinci engines that can be reignited in space, so that does provide the degree of flexibility in terms of repositioning in orbit. So that's not to be minimized.
Right.
And this is sort of to some extent a nascent sector, right? But more broadly speaking, if you're looking to compete on orbit, SpaceX still seems to be the major game in town here. It's just unavoidable.
And it makes it very easy for them to compete on cost.
Yes.
Which makes it difficult for other folks to keep up.
Yes. I mean, when the margins are this slim and you're just cut. I mean, you're not giving this thing a second coat of paint because you're worried about sort of just the the tyranny of the launch ratio. I mean, that matters. It really does.
But they also have Arianespace has a large backlog.
Yeah.
They have they're under a monster contract with Amazon for Project Kuiper, so they're gonna they have a lot of work coming their way. They have a lot of rockets to test, to learn from.
The market's there.
Yeah.
It's just a matter of them going and getting it at this point.
Yeah. So it's going to be busy, and I think a lot of folks are, like we talked about, trying to catch up. But I think these giant contracts give them years to experiment and figure out exactly how they can compete, if they can at all.
Yeah, and this is, I mean, to be fair, this is not a true marketplace in the sense it's like,
No.
you're not going down. Although I will say in Rocket Lab, you can go on the website and you just like book your own launch. There's a button there, almost like akin to buying a plane ticket on Expedia. So it's maybe that time is coming, but for the time being, the vast majority of these programs are taxpayer funded. So.
Yeah, and they're motivated to do better. At least they say they are. So we'll see how that plays out.
Yeah.
Well, great. Well, this was fun to do in person.
Yeah.
We'll have to do it again. We're going to be doing things a little bit differently over the summer. We're going to experiment with some formats and some different guests and different ways of telling some stories. But you'll see both David and I all summer, and we're excited about that. If you have feedback on, hey, how you were watching what played out in Iran and what that means for space, you can let us know. We're at Space Minds at spacenews.com. Thanks so much for watching. I'm Mike Bruce.
And I'm David Ariosto, and we'll also be doing one of these at the Ascend Conference in Las Vegas at the end of July, so stay tuned. Guest TBD on this. But thanks so much for watching and paying attention to our analysis and our guests here on Space Minds on Space News.